A circular doubly linked list is a variation of the traditional doubly linked list data structure where the last node's next pointer points back to the first node, creating a circular structure. Similarly, the first node's previous pointer points to the last node, completing this circular linkage. Because a circular doubly linked list incorporates three components in its structure, it requires greater memory per node and entails more costly fundamental operations. Nevertheless, this type of linked list facilitates straightforward manipulation of pointers and enhances search efficiency twofold. Here is a brief overview of how circular doubly linked list is structured. Node structure. Node in a circular doubly linked list contain two pointers, one pointing to the next node and other pointing to the previous node. Additionally, it holds some data. Circularity. The last node's next pointer points to the first node, and the first node's previous pointer points to the last node, forming a circular structure. This ensures that the traversal of the list can be continuous without reaching a null pointer. Operations such as insertion, deletion, and traversal are similar to those in traditional doubly linked list. However, care must be taken to handle the circular nature of the list properly, especially during the insertion and deletion operations. Traversal of the circular doubly linked list can start from any node and can proceed either forward using the next pointer or backward using the previous pointer until the starting node is reached again. Here is a basic implementation of circular doubly linked list in C language. These are standard C header files. stdio.h is included for input and output operations like printf, and stdlib.h is included for dynamic memory allocation functions like malloc and exit. Now let us see the node structure. This line declares a structure named node. Structure in C are user-defined data types that allow you to group multiple variables of different types under a single name. This line declares a member variable data of type int within the structure. This member variable is used to store the actual data associated with the node in the linked list. This line declares a pointer variable next of type struct node. This pointer is used to point to the next node in the linked list. Since a pointer to the same type struct node, facilitates the creation of linked list where each node points to the next node. This line declares another pointer variable previous of type struct node. This pointer is used to point to the previous node in the doubly linked list. A doubly linked list is a type of linked list where each node contains a pointer to the previous node as well as the next node. This allows traversal of the list in both forward and backward directions. So overall, this struct declaration is defining a node structure for a doubly linked list, where each node contains an integer data value, a pointer to the next node, and a pointer to the previous node. Next, we will see the function to create a new node. This function takes an integer data as a parameter and returns a pointer to a struct node. This line allocates memory dynamically using malloc function to create a new node. Size of struct node calculates the size required to store a struct node. Malloc function returns a pointer to the allocated memory block. The pointer is cast to struct node to ensure compatibility with the pointer type. This block checks if memory allocation was successful. If malloc function returns null, it indicates that memory allocation failed. In such a case, an error message is printed and the program exits with error code exit1. This part initializes the members of newly created node. New node data assigns the data parameter to the data member of the node. New node next and new node previous set the next and previous pointers of the node to null, indicating that this node is currently not linked to any other nodes. Return new node. Finally, the function returns a pointer to the newly created node. Overall, this function dynamically allocates memory for a new node, initializes its data and pointers, and returns a pointer to a created node. It's common function used when working with the linked list implementation in C. Now we will write the function to insert a node at the beginning. This line creates a new node with the given data using the create node function. This function dynamically allocates a memory for a new node, initializes its fields with the given data, and returns a pointer to the newly created node. This conditional statement checks if pointer to the head of the list head is null, which means the list is currently empty. If the list is empty, this line sets the pointer to the head of the list to point to the newly created node. Since this is the only node in the list, both its next and previous pointers are set to point back to itself, making it circular. This line sets the next pointer of the newly created node, which is now the head of the list, to point to itself, establishing the circular link. This line sets the previous pointer of the newly created node, which is now head of the list, to point to itself, establishing the circular link. If the list is not empty, execution continues from here. This line sets the next pointer of the newly created node, that is new node, to point to the current head of the list, effectively inserting the new node at the beginning. This line sets the previous pointer of newly created node to point to the node that was previously the last node in the list, which is head previous. This line updates the next pointer of the node that was previously the last node in the list, which is head previous, to point to the newly created node, that is new node, effectively linking it to the new node. This line updates the previous pointer of the current head of the list to point to the newly created node, effectively completing the circular link. Finally, this line updates the pointer to the head of the list to point to the newly created node, making it new head of the list. In summary, the insert at beginning function inserts a new node with the given data at the beginning of the circular doubly linked list. If the list is empty, it creates a new node and makes it head of the list, establishing a circular link. If the list is not empty, it inserts the new node at the beginning and updates the necessary pointers to maintain the circular doubly linked list. Next, we will see the function to display the list. This conditional statement checks if the pointer to the head of the list is null, which means the list is empty. If the list is empty, this line prints a message indicating that the list is empty. After printing the message, the function returns, terminating further execution of the function. If the list is not empty, this line declares a temporary pointer temp and initializes it with the pointer to the head of the list. This pointer will be used to traverse the list. This initiates a do-while loop that will iterate at least once and continue until temp reaches the head of the list again, forming a circular loop. Inside the loop, this line prints the data of the current node, which is the data stored in the node pointed by the temp. This line updates the temp pointer to point to the next node in the list, moving it forward in the list. This loop continues until the temp pointer reaches the head of the list again, completing the one full traversal of the circular list. After the loop terminates, this line prints a new line character to move to the next line in the output. In summary, the display function prints the data stored in each node of the circular doubly linked list. If the list is empty, it prints a message indicating that the list is empty. If the list is not empty, it traverses the list starting from the head node and prints the data of the each node until it reaches the head node again, completing one full traversal of the circular list. Now let us write the main function of this program. This line declares a pointer head to the head of the circular doubly linked list and initializes it to null, indicating that the list is initially empty. This line inserts a new node with the data 1 at the beginning of the circular doubly linked list, pointed to by head. Since the list is initially empty, this node becomes the head of the list. This line inserts a new node with the data 2 at the beginning of the list. This node becomes the new head of the list, and the previous head becomes the next node in the list. This line inserts a new node with data 3 at the beginning of the list. Similar to the previous step, this node becomes the new head of the list, and the previous head becomes the next node in the list. This line inserts a new node with data 4 at the beginning of the list. Again, this node becomes the new head of the list, and the previous head becomes the next node in the list. This line prints a message indicating that the following output represents the circular doubly linked list. This line calls the display function to print the elements of the circular doubly linked list starting from the head node. This line indicates that the main function has executed successfully, and the program should exit with the return code of 0, indicating success. In summary, the main function creates a circular doubly linked list with elements 1, 2, 3, and 4, inserts them at the beginning of the list, and then displays the content of the list.
Like, comment, and subscribe.